Alright, so in this video I'm going to go over how a redox titration can be calculated, and some of these, I've got two questions that I'm going to go over, and they can be a little bit complicated, so you need to make sure that you're paying attention. It works in the same manner as an acid-base titration, so you're really looking at finding moles of one substance with a chemical reaction, but they can be a bit tricky. Okay, so there are two important reactions that you guys just need to know. One is with thiosulfate. Thiosulfate will react with iodine according to this equation right here. So it would be a good idea for you guys to just know this equation. So as thiosulfate reacts with iodine, it actually turns the color into a pale yellow. So it's going to dilute the color, make it a pale yellow, and then you could actually add starch to this, and then that would react with it, this complex that you're forming, and it will become a blue color. And then if you wanted to, you could continue to add thiosulfate until the blue color disappears. There's another important reaction with permanganate. So if I have manganate with a 7 charge, so it's permanganate, it reacts as an oxidizing agent and an acid. So what that means, an oxidizing agent is a compound that will oxidize another one. So it will create an oxidation reaction, and then the permanganate itself will actually be reduced. So this is the reaction that happens when you put permanganate into acid. It's going to make a manganese ion with a positive 2 charge. Okay, so usually when you do this titration, permanganate will be in the burette, and at the end you'll see a solution that is a pale pink color. That tells you that that's when you stop the titration. Alright, so let's look at this one. This one is a reaction with iodate and thiosulfate. So iodate ions react with iodine according to this equation. So it gives you an equation, and it says a sample of sodium iodate with a mass of 0.311 grams is dissolved into water and made up 250 milliliters. So they made a solution, the entire solution is 250 milliliters. 25 milliliter portions are added to potassium iodide that has been dissolved into sulfuric acid. All right, so the resultant iodine is titrated against sodium thiosulfate. The average volume being 12.5 milliliters. What is the molarity of the thiosulfate? All right, so when we're looking at this, okay, there's actually two reactions that are happening here. They're adding sodium iodate into water, so they made a solution of sodium iodate, and then they added the sodium iodate solution, 25 milliliters of that, to potassium iodide. So that's the first reaction right here, this one. Iodate plus iodide ions, that's what happens when you have the potassium iodide here, which is dissolved into the acid, so there's our H pluses. So this is the first reaction. So it's actually two reactions happening here. And then this stuff was added to sodium thiosulfate. Well, sodium thiosulfate will react like this with iodine. So it's two reactions. All right, so our first equation is this one right here, and then our next one, our other equation, would be the one of sodium or thiosulfate, which comes out of the notes. And this is the complete reaction. It said that in the notes, so I don't need to worry about balancing it or anything like that. S4O6. Okay, so this is the second reaction. This is the first reaction right here. So let's see what information I'm trying to get. I want to know the molarity of the thiosulfate. So the thiosulfate is this. I need to know what the molarity is. So if I want the molarity of thiosulfate, I need two things. I need to know the number of moles, and I also need to know the volume. And it tells me that it's titrated against the sodium thiosulfate, the average volume being 12.5. So the volume of sodium thiosulfate here is 12.5 milliliters. So really what I need here is I need to know how many moles of sodium thiosulfate reacted. So now I need to figure out what I'm starting with. So I know the volume of the thiosulfate, but that's not going to come until the very end. So I know that I started with sodium iodate, and it has a mass of 0.311 grams. But this is of sodium iodate. Remember, this is they have two reactions here. Then the first reaction, we're reacting iodate with the iodide to make iodine I2. And then in the second reaction, I'm reacting the thiosulfate with the iodine. So I'm starting with sodium iodate here. And it also tells me that I dissolved this into 250 milliliters of water. And then I only used 25 milliliters when I did this. So I actually only used a portion of the iodate ions. All right, so what I'm going to do, well, if I want to go to thiosulfate right here, well, I'm starting with iodate. So I need to get to moles of just the iodate. Once I get to the moles of iodate, I'm reacting the iodate with the iodine ion, I minus, to make I2. So once I make the I2, then it reacts with the sodium thiosulfate. So I need to go from moles of iodate to moles of iodine, because that's going to tell me how much iodate reacted. And then I can go from the iodine, just the I2, to the sodium thiosulfate. So these are the steps that we're going to use. And it's not going to be quite as straightforward because there's two different reactions here, and then also because you're only using a portion of this solution that we're making up. So we need to figure out how many moles of iodate I actually started with, because I didn't start with this many grams of it, because I dissolved it into water, but then I only took a small portion of that. So first thing I need to do, I need to figure out how many moles of iodate I actually reacted. So I need to figure out the molarity first. So I'm going to start with 0.311 grams of sodium iodate. That's what I'm starting with, the sodium iodate. All right, so now I'm going to go to moles of this with my grams. So 1 mole is equal to so many grams of the sodium iodate. So it's 197.88. All right, so now I know how many moles of the sodium iodate I put into the solution. I really only care about the iodate, just the iodate by itself. So whenever I dissolve this into water, it's going to break apart into 1 sodium ion and 1 iodate ion. So it's a 1-to-1 ratio. For every 1 of these that I have, I'm making 1 mole of iodate. So I'm going to go to moles of iodate. And this is because when I dissolve this into water, 1 mole of this will create 1 mole of that. So it's a 1-to-1 ratio. All right, so when I do this, I'm going to get 0.00157 moles of iodate. All right, so now I need to figure out my molarity. So my molarity of just the iodate is going to be this divided by 250 milliliters of solution. So it's 0.00157 moles of iodate divided by my volume, which is 0.25 liters. So my molarity is actually 0.00629, and that's for my iodate. That's my molarity. Okay, so this is the part that might be a little bit confusing to some people. And this is where you have to say, okay, I can't just jump from moles of iodate to moles of my iodine. So remember, I'm going from moles of iodate to moles of iodine in the first reaction, and then I can go to moles of sodium thiosulfate. Okay, so I'm starting off with, I have a molarity, and it says that I only use 25 milliliters of this solution. So I'm really starting with 25 milliliters. It's a portion of it. I can't use this. It's not 0.00629 moles because I only used a small portion of that solution. Okay, so now what I'm going to do, I'm going to go from my volume of my iodate to moles of my iodate that I actually used. I only used 25 milliliters of this iodate solution. Okay, so I'm still going. I need to know how many moles of iodate actually reacted here. So my molarity is 0.00629. All right, so now let me just go ahead. I'm going to solve, figure out how many moles of iodate, or actually, I have iodate here. If I want to go to moles of iodine, I can just simply go to iodine with the chemical reaction above. So now that I'm in moles of this, now I can go to moles of the other substance. So moles of iodate on the bottom, moles on top of moles, I look at the coefficients, and that's the first reaction. So for every 1 mole of iodate, I'm going to produce 3 moles of iodine. All right, so now if I go through and calculate that, I could stop here, but if I'm actually in moles of iodine and I want to go to moles of a different substance, I can do that. I can just continue. So I'm going to go to moles of my thiosulfate. So once you're in moles of a substance, if you have chemical reactions, you can just go to moles of a different substance. So it doesn't matter that I'm changing into a different equation. I'm going to use this equation now. So for every 1 mole of iodine, I'm going to use up 2 sodium thiosulfates. And then at the end, when I do the calculation, I have 9.435 times 10 to the negative 4th moles of the thiosulfate. But that's not what the question was asking. The question was asking for the molarity. So remember, I have my volume. I needed my moles of sodium thiosulfate. So now that I have my moles, I can just simply divide it by the volume, which is 12.5 milliliters. So I'm going to convert that to liters. And that's what I'm going to get. And then afterwards, I'm going to just divide, and I will get 0.0755. Okay, so there's a lot of steps here. But remember, if you're going from right here, if I want a molarity, I need moles and liters. It gives me the liters of the thiosulfate. So I'm going to need to get my moles. So if I want moles of this substance, I need to go from my moles of iodate to moles of iodine, because that's what's reacting with the thiosulfate in the second reaction. And then I can go to my moles of thiosulfate.